true and false question. I thought that was true. It says there are no pentagons, regular or non-regular, that will tessellate the plane. Because I thought that pentagon interior angles, it's not a factor of 360.
That's right. So around, if we take regular ones, they've got to be a factor of 360 in order to fit there because they're all the same. But if they don't have to be the same, then you can take them and add different amounts and different angles. And what I was testing you on is, did you remember Marjorie Rice? This homemaker of, how many kids did she have? 5 kids who discovered all of those different pentagons that would work. That's kind of what I was... Okay.
And then I have another question on the matching with the demi-regular, did I say it?
Semi or the demi?
Both. So the demi-regular tessellation, it's saying that it's a semi-pure tessellation where the arrangement of regular polygons at each vertex is not the same.
Not the same. So you pick a vertex somewhere in the tessellation, you pick another one, their designations can be different. If you find that, that's demi-regular.
Okay. It just confused me because it said it's a semi-pure tessellation, but that's a demi-regular tessellation.
Mm-hmm.
You know? But
the regular comes from it's using the regular polygon shapes. Okay?
mm-hmm.
The semi-pure means it's got more than one shape. It's not pure. Pure says you have one shape. The tessellations you're making are pure.
So
You're going to make this dog or this fish that is going to be all over your screen, just that one thing. That's pure.
So, can semi be demi?
Semi-regular and demi-regular are mutually exclusive. That means they cannot be the same. Okay? But the term semi-pure, I think that's where you're getting it mixed up. Semi-regular and semi-pure. Those don't mean exactly the same thing. Okay? Did that cover the quiz questions? Or okay, I want to hit a few really important things on the tessellations. Your own tessellations that you're building. I have... Well, let's do this introduction real quick first. Let's jump to this. If you are doing Sketchpad, we have just a few. This is how you arrange it. It goes in tabs. So here's your introduction. Start off, you tell me what piece, tell me what you're going to do. Then you say, my first step, I do this, and you state out here what that is. Then you do your next step, and you tell what happened to get that. Then number 3, you do the next step and tell how that was done. 4, so on, what happens. 5, okay, we showed you this now. With the GeoGebra, they don't have tabs because it's a different program. So what are you going to do? Here's what you're going to do. You're going to call up GeoGebra. You're going to you will do the very same thing, except instead of creating tabs, oh, by the way, those of you using Geometry Sketchpad, if you will say create a new tab and duplicate the previous page, it will bring everything to that next tab, and then you just have to make the change to it. Okay? So then you take that changed one and move it to the next tab, and then make the change on it. The difference is here for those of you who are doing GeoGebra. So you'll come up, and I'm going to just do a regular polygon here. I'm going to do this, and I want 4 sides. And there it is.
The instructions are a lot different.
Yeah.
Different than what?
Like they make you get a point and then like they like have you do a really long way.
Yeah, and doing those, I'm doing this really fast because I want to show you what's going on.
Could you do
Okay,
it that
so,
way?
well, the problem with this is you've got this polygon, and really all we care about this, if I'm using a square, all I really care about are the corners, the vertices. Why? Because I'm not going to use this straight segment. I'm going to go grab this segment tool. If I get the right one here, this segment tool, and I'm going to make, that's not what I want. Cancel. I want this one. I'm going to go here, here. How come it's not building a segment?
I think you need to put points there first and then use the segments to, I don't know, that's what I did, it took a long time.
There we go. Okay, you see how I've done this? And then I would select just these here and translate them over here if I'm doing the translation. Okay, but what I need to do is, I want to save a picture of just my square with saying I'm starting with a square and I'm doing a translation tessellation. And then I save it. And I call it intro test 1 or something like that. Because this is my tessellation number 1 and it's my introduction. Then I get to here and I say, I come in and get a text box here and come out here and say, I have created a design on one vertical side. Hit OK. And I move that to where I want it, right there. Okay. And I save that as test 1A. My tessellation number 1, part A. Now what am I going to do? I'm going to select all these points here that I made. Let's see. These segments, actually, right? So I'm going to select all of these. And what am I going to do? I'm going to translate them by a vector. So notice I have to select objects to translate. So I do that. Come on. Why is this thing?
Because it's a Windows machine.
You what?
Because it's a Windows machine.
Oh. Let's see if I can do this. Highlight them like this. There we go. There we go. Now, I've selected the ones I wanted to do. Now, the vector. I'm going to do it from C to D. Should have done it. C,
Yeah, GeoGebra's not my favorite thing in the world.
D. Okay, let's try it again. We're here. We go to translate. We select the points. And now we're going to go from B to A. There, it worked. I did the same thing last time. I don't know why it didn't work. All right, so now what am I going to do? I'm going to come and change this right here and say, I selected the design on the vertical side and I shouldn't worry about my spelling because I'm not saving this, but translated it to the left using vector, what was it? BA.
Everything.
Vector BA. Okay? And I say okay. There it is. And now I save that stage as test 1B. Does everybody see what I'm saying? So each step, with the explanation for that step, I save as a new file name. All right? You with me? Okay. Then you get it all done, including your second to the last step will be you've got your figure, you say I decorated my figure. The very last step will be I moved the separate figures, I either rotated them or I slid them so that they would tessellate the plane, and you tell how you did it. That one will be fairly detailed. Does that make sense? And so you may have 8 files. You may have 6 files, somewhere in there, depending on what you're doing and how it's doing it. Then, how are you going to send me? I don't want all 6 of those files. What do I want? I'll show you what I want. There is a place called GeoGebra Tube. And if you go to geogebratube.org, you will go in and register. You will have an account here. It's free. You'll have an account. Okay? And that is detailed in, if you'll go to today's assignment, just recently, today's assignment, here's what you're going to do. Let's go there. Today's assignment is called, what's it called? Get the right class. That helps. Making your own tessellation. When I open this here, at the bottom, right at the bottom, it says how to register and upload files to GeoGebra Tube. Okay, you get this copy and it will walk you step by step, real easy. Okay? Then, once you've got it registered, then what you're going to do is you've got all these files, test 1 intro, test 1A, test 1B, test 1C, all uploaded there. Then what you're going to do is you're going to how to add your tessellation files to a collection. And it will show you how to do that. Okay? Inside of GeoGebra Tube. Then, once you've got that all added to a collection, here's the last one. How to submit your complete tessellation project. It will give you one URL linked to that collection that you just made. You will paste that into the place where you submit your first tessellation. Then what will I do? I will go and click on that, and it will take me right to that tessellation, which will be a web page that'll have intro, A, B, C, whatever, right there, and I just click through them and look how you did. Does that make sense? Not only can I look through them, but if you send that collection URL to anybody else, they can look through it. Or if somebody searches on yours with a certain name or whatever, they can actually find it and look at it. Does that make sense? This is out there for the entire world. It's for your students to see what you've done. You can show them. Let me show you how to do this. And you can actually show them your 2 collections of your 2 tessellations. Does that make sense? Those of you who are on Sketchpad, you will not submit the URL to your collection. You will submit one single file that has all the tabs in it. Does that make sense? Now, one last thing I need to talk about. How do you shade the inside of a figure? Well, if you are in Sketchpad, let me show you how you have to do it. If I want to shade the inside of this figure, I must do it this way. Watch. Click here, that point, that point, that point, that point, in order. Don't miss any of them, all the way around, because if I miss them, I'm going to stop right there, but I would continue on around, and you have to click those, and then go up to construct. You'll see what happens since I didn't finish all of them. Construct polygon interior, and it just filled the ones that I clicked on. Okay? But you'll go all the way around, and now I can change that to any color I want. Well, maybe. There we go. I can change it to any color I want. That's how you do it in Sketchpad. How do you do it in GeoGebra? You do it the very same way that I just showed you, because the only thing that can be filled in GeoGebra, at least in the current version, is, let's go to GeoGebra, is the polygon. So what you will do is, you will go up here to polygon, and you won't say regular, you'll do just plain polygon. And you'll come over here, and on the figure that you have done, you'll click here, and 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 here. See how it's filling it? And here, and here, and so you'll have to click around each point just like they do in Sketchpad. When you get done, it will have an irregularly shaped polygon which is connected by all of your vertices, and then you can change that polygon color.
And how do we do that?
Okay?
So I feel like
I'm going to just go, oh, by the way, when you're done, you have to come back to the beginning. Now it fills it. Now notice it's polygon 2. So polygon 2, if I double click this, the object properties take me, and I see color as one of them, and I say I want that blue, and I close this, and now it's blue. And you can change the opacity, how transparent it is, so you can see through it more or less or whatever. Okay? But you have to click around. After you've built the whole thing, you have to click around it with the not regular polygon, just a plain polygon tool, and that will allow you to fill it. Okay? Those are the hardest things right now, I think. So just take a step at a time on GeoGebra, save after each step with each explanation. Then load that same file, or keep it right there, add one more step, and then put an explanation of what you did on that step. Save each one. So you'll save each step with the explanation of that step as you move along. Questions?
So, on Tuesday, you said to color like just our original image before tessellating it, like
Yep.
in terms of, does that still work on GeoGebra?
Yes. So once you have that and you've colored the inside, and now you either slide it or you twist, rotate it or whatever to fill your whole plane, the thing of it is, the whole plane will be filled with the color,
Yeah.
but all you have to do is then click on that one
Yeah.
and change the color of that one so you get a nice design.
I just want to
Yeah.
make sure it still works on GeoGebra.
It does. Yep.
I don't know if I should come to you individually for this, but like I tried the rotation one, and I'm like, I can get it this way, but I can't ever find a vertex to fill those ones,
Okay.
and I don't know.
Come to me individually.
Okay.
What you got to make sure that you really want a rotation. Do you want a rotation or do you want a translation? I mean, what is it how is it? And each one of those methods, it depends on which method you're using, whether you rotate or translate to get it to fill the plane. Right now you're trying to get it to fill the plane, right?
Right. Yeah.
Okay. So, yeah, you can come see me.
Are you going to be in your office today or no?
I'll be there all day except for the devotional. And
Thursday.
be here till 5. Yep.
Okay, cool.
Yep. So come on by. Okay. What time is this? Oh, we have half an hour, right?
Yeah.
Okay. So get going on these so that you can come on Tuesday with some questions, then you'll still have the rest of the day to finish things up. Thanks. Okay, this next activity. In order to talk about it, we need to go over this. Did everybody remember this homework assignment right here? It's important that we understand this assignment. Mikhail, can I get you to jump up and answer that question and tell how you know how to get that?
This is from the homework last night, and we just took the chart, and the first question asks, what is, and then it has the circle, the main shape, and then the upside down part. And we don't entirely know what the process is, but we know that the middle shape of the equation is the main shape.
It's the operator.
Yeah,
It's like a subtract or a
multiply.
multiplication or addition or whatever.
So we take the first shape, and we find it on the left-hand column going up and down, and then we take the middle operation one, and then the other shape as well, and we just go down and we meet in the middle, and we find out that the answer is the smiley face.
Does everybody see how we got that answer? Okay, the next question was, is this operation closed? Is this set closed under this operation? You said that really fast. Tell us how you know.
Because all of those shapes are included in the set. I mean, it may not have all the shapes, but it is still closed because all of those shapes are included in it.
So what would have made this so it wasn't closed, this set not closed under this operation? What would we have seen? What would we find?
A different shape in your answers.
Yeah, out in here I'd find something like, let's see, we've used diamond, spade, like a heart. Heart's not in our set that we're operating on, but if we found a heart out here, we would say it's not closed. Okay? It's like when you take a whole number and you subtract another whole number, you don't always get a whole number from that set. You can sometimes get a what? A negative. So you've got to go to the integer set to get it. So if I had to go to a set that had a heart in it, if there's a heart out here, we would say this is not closed. Does that make sense? All right. What was the next question after the closure question? Make sure we go.
Identity.
Is there an identity element? What does identity mean?
Identity means if you multiply or you add, it's whatever you give to that, that'll make it stay the same. So like 1 plus 0 equals 1, so 0 is the identity.
0 is the additive identity because when you add 0, it
It stays the same.
does nothing. It stays the same. 1 is the multiplicative identity because when you multiply by 1, it does nothing. So what we're asking is, what is the do nothing here? And how do we know? Yes, Catherine.
It's the diamond, because whenever you take your first shape,
My first shape, let's say this is the first shape.
then you spade it or whatever you do to it, you use your operation and operate on it.
Okay?
The only shape that you can do that to get the first shape again is the diamond. So if you do
So
a smiley
what
diamond,
brings me
it's-
back to get the, right here, the diamond did nothing to this. What did it do to the wheel? Nothing. What did it do to the diamond? Nothing. What did it do to the spade? Nothing. Right? That's how we know that this is the identity element, because it does nothing. Okay, the next one was, what is the inverse of, what did we ask you? The smiley face? What's the inverse of the smiley face? Well, what is an inverse? Yes and no. inverse. It is the, and I'm not going to use the word number because these aren't numbers, and we can talk about these with it. It's the element. The thing, it's the thing. The element that yields the identity. So, if I ask you what is the additive inverse of 3, what is the additive inverse of 3, I'm asking the question, what would I add to 3 to get the identity? What's the identity for addition? 0. What goes in the blank? Negative 3. Negative 3 is the additive inverse of 3. Okay? Why is it? Because it produces the identity, and that's the definition. The reason I said yes and no is because if I take 3 and I want the multiplicative inverse, that is going to be the thing that I multiply by to give me the multiplicative identity, which is 1. And this isn't negative 3 now. It's what? 1/3. The additive inverse can be thought of as the opposite. The multiplicative inverse can be thought of as the reciprocal. Because if I want 3/4, I want its multiplicative inverse. I ask, what do I multiply by to give me the identity? Well, that's going to be 4/3. So that's the multiplicative inverse of this. So, what is the inverse of smiley face? I'm asking the question, what do I shamrock smiley face with to give me the identity, which we said was diamond? So I'm asking, what element produces the identity? How do we get that? What is it? How do you know?
Because if you multiply the smiley face with the spade, you get the diamond, which is like.
So I look here and I look over here to find what gives me the diamond, and it was the spade that did. So therefore, that must be our inverse. Does that make sense? All right. Were there other questions there that we... Oh, I think we asked, was it commutative?
Yeah.
Is it? If I do... What did you say the answer was to this one?
The smiley face.
Smiley face. Because if we go this shamrocked with that, we get smiley face. What if we do shamrock or spade shamrocked with this in the other order? We still get. So what's that mean? That this operation appears to be commutative, right? Okay. Are there other ways of telling besides that? Okay. Well, what we're about ready to do, yeah, there are, but nobody knows, and I'm not going to tell you because it's not going to be meaningful to you if you have not seen it. Or all right, what we're going to do is we're going to do some consecutive transformations. We're starting with this figure. It's got A at the top, A at the top, B goes right here, and then there. Okay? And it says there's 3 lines of symmetry. There's L1. This one's L2, right? L2. And then this one is L3. 3 different ways I can reflect this. One over line 1, one over line 2, and one over line 3. Okay? There are 3 different rotations I can do with this. I can take this center, and if I had done these right, they should have all intersected in the same point, right? Take this center, and I can rotate A to C. How far and it would then map right back onto itself. How many degrees is that? 120. So this rotation is what we're going to call R120. But I could also take A and rotate it clear around to here, and A would now end up where B is. If I rotated it how far? 240. So we're going to call this one rotation 240. And then I can even take it and rotate it all the way around, and we call that rotation 360. And all three of those rotations will cause the triangle to be right back on top of itself, right? Okay, so here's what we need to do. Let's take the first one together. The figure called L1. What I want you to do is I want you to look at if we took this triangle labeled A, B, C, and we reflected it in the line L1, that's this one, I would get a new shape that's the very same shape, but the letters would be in different spots. Right? How would it be over here? Instead of B, I'm going to have C because it got reflected over here. Over here, I'm going to have B, and up here, why didn't A change places? Because its point is on the line of reflection. And so it gets reflected right back to itself. So I would like you to label your L1 diagram like mine. A, C here, and B here. You with me? Okay? Now, start over again. We go back to the original. We're going to go, let's see, that was L1. L2 is going across, right? Is that the...
Your,
Pardon? I didn't bring my glasses today, and that's... Is that L2?
Yeah.
Okay, so going across to L2. If this is the original, right here, and we reflect it in this line, how is it going to be lettered now? C will be in the same spot because it's on the line of reflection, and A is going to go where B is, and does everybody see across here? So my new, this is for L1, this is for L2, it's going to be C, and this is going to be B, and this is going to be A. Does everybody see what I'm talking about? All right. Finish with your partner the other 4 transformations and check to make sure that they are correct.